Okay, in this video, welcome to video 2, day 2. And in this video, we're going to look at the relationship between a linear and exponential function. Our objectives today is to identify a function as either linear or exponential, and then write an equation to model the function. Let's recall from the previous video, a function is linear if you add or subtract the same number each time. If it's linear, it can be modeled with the expression y equals mx plus b, where b is the beginning amount and m is the slope. Now recall from before that the slope is going to be the amount that's added or subtracted each time. Now the exponential form is probably a little is newer to you than the linear. The exponential form can be written as y equals a times b to the x, where a is your initial amount and b is what we call the common ratio. It is the amount being multiplied or divided each time. So let's look at some examples. And in these examples, we have to determine whether or not the relationship is linear or exponential, and then write an equation. So in this first example, we have 800 books. A library has 800 books, and every year it adds 500 more. So is this relationship linear or exponential? Well, because we're adding the same amount each time, because we're adding 500 books each year, that makes the relationship linear. If we were multiplying by 50 books each year, then that would make it exponential. But since we're adding 500 each year, that makes it linear. The initial amount is how many books we started with. So in this case, we started with 8,000 books. The common difference is the amount that we're adding or subtracting each time. In this case, we're adding 500 each time. So our equation is y equals mx plus b. Remember, m, the slope, is the common difference, and b is the initial amount. So we can write the equation as 500x plus 800. In this next example, we have a customer going to the gym, and they paid $50 for their yearly membership and then $3 every time they use the gym. So the question is this linear or exponential? Well, because we're adding $3 each time we go, we're paying an extra $3, that makes it linear. The initial amount is how much he originally paid for it, which is 50. So if he never goes to the gym again, he still would have been out the $50. So remember, the common difference in this case is what's being added each time, which is 3. So based on this, we can write the equation of the line. So remember, it's the y equals mx plus b. M is the common difference, and b is the initial amount. So can you write the equation of the line? Very good. Y equals 3x plus 50. Okay, in practice 1C, we have a bank account, and the bank starts with $10, and every month the amount in the account is tripled. I don't know where this bank is, but I need to find it. So is this linear or exponential? Well, because the amount is tripling each time, so that means each time we're multiplying it by 3, that makes it exponential. The initial amount in the account is the amount we started with, so that's $10. Our common ratio is the number that we're multiplying by each time. So in this case, the amount we're multiplying by each time is 3. So it's the common ratio is 3. So this is how we would write that equation. We have y equals a is 10, and b is going to be 3. And x here represents months. Okay, in practice 1D, we're at a carnival and we have 50 ride tickets, and each time we ride we have to pay an additional 6 tickets. So is this linear or exponential? Well, every time we ride, it's like we're subtracting $6. So that would be linear because we're subtracting by the same amount each time. The amount of tickets that we started with was 50. And so our common difference is going to be 6, and it's negative 6 because we're subtracting 6 tickets every time we ride. So our equation would be our slope is negative 6 and our y-intercept is 50. Okay? In problem 1E, we start with 20,000 owls in the wild, and every decade the number of owls is halved or cut in half every decade. Decade means every 10 years. So is this linear or exponential? Well, each half means that each time we're dividing it by 2. We're cutting it in half means to divide by 2. So if we're dividing by 2 each time, that means that it's exponential. And we're starting off with 20,000 owls. So our common ratio in this case would be 1/2. So we would write the equation of the line, the equation of the function would be 20,000 is A and B is 1/2. Now notice I did x divided by 10, and the reason I did that is because this happens every 10 years. I will not give you any that complicated on your quiz or test. Okay, so now let's look at a table and determine, using the skills that we learned from the first video, whether or not it's linear or exponential. We're going to find the initial amount and then write the equation of the line. Okay, so equation of the function or a line. All right, so is this linear or exponential? Well, I noticed that my y values are increasing by 3. So I went from 2 to 5 plus 3, 5 to 8 plus 3. So this is linear because I'm adding 3 each time. My initial amount is when x is 0. So when x is 0, I start off with 2. So my initial amount is 2. And because this is a common difference, and this is a linear equation, my equation of the line is y equals mx plus b. So b is 2, and my slope is 3. Okay, looking at this one, I noticed that my y values go from 3 to 6. So I could be adding 3 each time. But when I look at the next one, I went from 6 to 12. I was not adding 3. So what other relationship can I see? Well, maybe I'm multiplying by 2 each time because 3 times 2 is 6. So looking at 3 times 2, I get 6. And then 6 times 2 is 12. 12 times 2 is 24. So I notice that each time I am multiplying by 2 each time. So that makes the function exponential. The initial amount, again, is what at x equals 0. So at x equals 0, I started with 3. And as I said before, my common ratio is 2 because I'm multiplying by 2 each time. So my equation is y equals 3 times 2 to the x. 3 is the initial amount and 2 is my common ratio. Okay, so what I'd like for you to do is I'd like for you to complete problems 2 through 9 in your packet for classwork and homework. And remember, there's an online assessment that needs to be done as well. So you have quite a bit to do today. You may have to do some of this for homework. I'll see you when I get back, and have a great afternoon.